Okay, so I saw you guys were having a little bit of trouble with question 18 in homework 1. So the question gives you a cubic polynomial, in my case x cubed minus 4x squared plus 15. And it wants you to graph, give the domain, and then determine peaks and valleys and intercepts. So I'm going to take this function, x cubed minus 4x plus 15, and I'm going to use this online graphing tool called desmos.com. It's free. And I'm just going to type in my function. So y equals, and I'm going to have to go back and forth because I don't know what the function is. So x cubed minus 4x plus 15. X cubed minus 4x squared plus 15. Let me just double check that I typed that right. X cubed minus 4x squared plus 15. X cubed minus 4x squared plus 15. Perfect. So now I'm gonna zoom out so I can see the graph. And in fact, if you look at the math lab, it tells you that they're using minus 16 to 16 and minus 8 to 8 as their window. So now what you should take away from this graph is that it's falling on the left and rising on the right. Its y-intercept is positive, and then this valley down here is also positive y value. So we're just going to look for which graph looks like that. So falls on the left, rises on the right, y-intercept that's positive, and a valley that's also positive. So looks like this would be C. Good job. Okay, now let's talk about the domain. So this function is a polynomial. It's a cubic polynomial, and in a polynomial you can use any x you want. So the domain has no restriction, a set of all real numbers. So now it's asking you for the peaks of the function. So a peak of a function is like the top of a hill. It may not be the highest part of the graph. It could be the highest part of the graph, but it doesn't have to be. It could be the lowest part of the graph, but it doesn't have to be. It's just where your graph is changing. So in our graph, we do have a peak, and the peak is right here. And you'll notice I have my mouse and nothing's happening, but if I just click and it puts a point on my graph, and it tells me that that point is 0, 15, which we kind of knew, but it could have been off. So 0, 15. So my peak is the location 0, 15. Now let's go back and look what the question is asking. The question wants the x value. So of that coordinate 0, 15, which one is the x value? The 0. The 0. So it has a peak when x equals 0. Cool. Now let's see where it has a valley. So again, I go to my desmos.com, I find the valley, and I click on it, and look at this one. This one's a decimal, 2.667, 5.519. So now it's asking for the x value, and what's its rounding? Let's see, type an integer or the decimal rounded to 2 decimal places. So my x value would be 2.67-ish. You can't see me, I'm like waving my hand like I do in class, like 2.67-ish. So 2.67. Good. Now we want to find the intercepts of the function. So are there x-intercepts? Are there y-intercepts? Well, let's go look at our picture here. So now we can see that there is one single x-intercept at negative 1.632, 0. and there is one single y-intercept at 0, 15. So let's type those in. Negative 1.632 is my x-intercept. So here, there's going to be both. The x-intercepts, it says, now look, read the directions. Type an ordered pair using integers or decimals, round to 2 decimal places as needed, use a comma to separate if you have more than one. So here I have to type the whole ordered pair. So what I like to do is like put in the parentheses and the comma so I don't forget them when I'm doing my decimals. And I'm just going to go back and get that number for the x-intercept, negative 1.63, comma 0. And for the y-intercept, that was 0, 15. Okay, so that tool, Desmos.com, is available for free to everyone. You don't need to purchase a $100 calculator unless you choose to. Desmos will work, and I think it's a little bit easier than the calculator because you're able to just click with your mouse.